Now we're going to find asymptotes of a rational function, one that's obviously a little more complicated than what we've looked at so far. Um, so let's look at vertical first. All right, vertical asymptotes can occur at the x values where the function's undefined. So essentially that's where the denominator is equal to 0. So what we're going to do is we're going to set the denominator equal to 0. In this case, x squared plus 7x plus 12 is factorable. So when we factor, we get x plus 3, x plus 4. We solve for x, and we get that x is equal to -3 or -4 would make that denominator 0. So there's possible asymptotes at x equals -3 and -4. When you actually graph this function, you can see that the graph is not defined at those places. So those are both asymptotes. So essentially, finding vertical asymptotes, set the denominator equal to 0, solve, and those should be your vertical asymptotes. For horizontal, a little different. So how do you find vertical and horizontal asymptotes of a rational function? So in this case, there are three cases. There's three different possibilities for what can happen when you're looking for horizontal asymptotes. Case one, the degree of the numerator is less than the degree of the denominator. All right, so if that's the case, all right, whatever, just get that to go away. All right, so when the degree of the numerator is less than the degree of the denominator, a lot here to say that the horizontal asymptote is at y equals 0. So if the degree of the numerator, which in this case it's 1, is less than the degree of the denominator, which in this case it's 2, the asymptote is at y equals 0. All right. Case 2, the degree of the numerator is greater than the degree of the denominator. So in this case, in this example down here, degree is 2, degree is 1. So when those are the cases, when that's the case, there is no horizontal asymptote. All right, so case 1 was when the numerator had a higher degree. Case 2 is when the numerator had sorry, case 1 is numerator has a lower degree. Case 2, numerator has a higher degree. Case 3 is when their degrees are equal. All right, when their degrees are equal, it's a little more complicated. But it's actually not this complicated, so let me explain. You can do that long division thing we were doing in example 1, and you get that 2. That means the horizontal asymptote is at y equals 2. However, another way to look at it, and a simpler way to look at it, and what I would do if I was you moving forward, when the degree of the numerator is equal to the degree of the denominator, so that's the case, the horizontal asymptote is the ratio of the leading coefficients. So you really just have to look at the leading coefficients, because when you do that long division process, this number is just going to be the leading coefficients divided by each other anyway. So again, just looking at the leading coefficients, 2 divided by 1 is 2. So the horizontal asymptote would be at y equals 2. And that's how you can figure that out. So we've got two examples to try. I was thinking I could work out the first one with you right now, and then you'll try part B. Okay. So the vertical asymptotes are when, again, when the function's undefined. So when the denominator is equal to 0. So let's just set x squared minus 2x minus 8 equal to 0. This does appear to be factorable. You're going to have x. Maybe it's not factorable. Signs have to be opposites, right? So I was thinking it was 4 and 2, but they... Oh, okay, I'm just not thinking properly. There we go. All right, so then you have vertical asymptotes at -2 and 4. All right, the horizontal asymptote, again, we're looking at the degrees of numerator and denominator. Since they're equal, we find the ratio of the leading coefficients, and in this case, the ratio of the leading coefficients is 2. So then the horizontal asymptote would be at y equals 2. So these would be your three asymptotes for that function in part A. All right, I'm going to pause it, you try B, and then when you unpause it, we can compare answers. So we set the denominator equal to 0. Since there is no linear term there, I use square roots, ended up with x is equal to plus or minus 2. So that means you got a vertical asymptote at x equals 2 and x equals -2. Since the degrees are the same, it's the scenario where you're finding the ratio. Um, so 1 divided by 3 is 1/3. So the horizontal asymptote would be at y equals 1/3. All right, let's look at example 3.